Okay. I'd guess. All right. I don't know, man. I'm going to put the link in there with you. Got no notice. That's the link. Yes, that's your permanent link. Okay, we're in. We're live, everybody. Welcome to part 2 of Saturday Night Rabbit Hole, and we've had some technical difficulties with the cameras and the like, and don't know why they had problems, but we're trying to mitigate those problems for you, and we'll try to solve them as soon as they want to be solved. So yeah, we're back live. As you can see, there's Canuck. All right, buddy. We'll hang up the phone now. Can you hear me now?
Yeah, I can hear you good.
All right.
Can you hear me?
Yeah. Seems like we got whatever resolved. So go ahead and post the link in. All right. Welcome back. Part 2. Recording here for the rabbit hole. Seems the camera doesn't like us. So sorry.
Yeah, we overloaded the video.
I guess. Yeah, display capture. There we go. Page. There we go. Yeah, we'll get it resolved. You know. Yeah, both are 5x5. Okay, we're but I don't know what's going on, but I did turn that video off, and so it's not on. I mean, it is on, but it's not on. I flipped it off. But you got to put the link out there because I don't have. Wait, I do have the links, right? All right, I do have the links.
Yeah, they should be in your whisper. Yeah.
Yeah, let me go back to the one, the only Canuck. Dun, dun, dun. All right, so
I don't know
the Panamint.
They heard. Yeah, I don't know if they heard the Death Valley and the
no
old or the Town Pass one. So we probably should start with them again.
All right, I'll start with that one. There's Panamint. There's Town. Maybe there's this one. Open a new tab.
Yeah, I put Death Valley, then
Town Pass.
Then Town Pass, and then Panamint.
Okay, so I got Town Pass on there, and open a new tab.
I don't know if they heard
Death Valley's. Did not.
Death Valley.
Did not. No.
So
and the research publication. All right. So refine Holocene slip rate, Western Central segments, the Garlock, recording altering millennial scale periods, fast and slow slip. We talked about that article. And
so we were getting ready to go into Death Valley.
All right. All right. So hold on. I'm going to make sure I open up these other ones, because there's 3 more over here. All right. So put this one here. This is where we started. Owens Valley is over here. Nevada is over here. North Cascades is over here. We're in Town Pass. Is that where we're starting?
We'll do Death Valley again. If
all right. All right, bud. Let me get it here. Hurricane Center, share this. Go back. All right. We are live. We're doing it. I got Town Pass here, so let me Panamint. You don't want Panamint. You want Death Valley. Death Valley start. Share this instead. All right. We're good, bud.
Yeah.
Talking about Death Valley.
So before I read that off, I gotta say again, Death Valley Fault Zone is broken down into 3 segments. So the North Death Valley Fault Zone, the Black Mountain Fault, and then at the bottom, the South Death Valley Fault Zone. And then there's another one that comes off it on the side. It's called the Furnace Creek Fault.
That is so weird, man.
And we'll see it when we go into the maps here next, after I explain the main faults. So the Death Valley Fault Zone type of fault is right lateral strike slip. Length is 115 kilometers for the length of zone. Total length of fault segments is roughly 200 kilometers. Nearby,
so basically from down here all the way up to way up here into Nevada is Death Valley.
Yeah, because it's like super long. Most recent surface rupture is Holocene, they think. Slip rate is roughly 3 millimeters a year at south end, considerably less at the north end. Interval between major ruptures, roughly 1,000 years with a question. So they're not quite sure. Probable magnitudes between 6.5 and 7.3, but in the newest studies I looked up, they said it can go as high as 7.7.
Right. I've heard 7.7 to 8.2 somewhere in there. So this is the southern section, right where it hits Garlock. That's the southern section, and the middle section's in here, and then the northern section's up here. The Fish Lake Valley Fault turns into the Northern Death Valley Fault Zone, which is Black Mountain Fault Zone, which is in the central. All right. Furnace Creek is where it splays off, right? Goes right up in here to Pahrump. And you've all heard about Pahrump and all the earthquakes happening out here. They may be linked to this Death Valley because Furnace Creek leads right into Pahrump. And so, stop, damn thing. We need to get the Nevada one of this conservation map and then be able to compare the two.
When we do Nevada, but I don't want to get into that. Yeah.
Correct. Yeah. All right. So
because the Nevada one is very similar to the California one that we use.
So the probable magnitudes 6.5 to 7.3 out there. Most of Southern Cal, the largest quakes that I'm hearing is that what the heck? There we go. There. All right. See, it's killing my ears. Is up to 8.2 out there because it's so damn long that that it's broken down into 3 sectors. Much like most of the quake faults that we talked about earlier. If you remember, we talked, about the Laguna Salada, which is the bottom part of the Elsinore fault, which leads into some more faults in the north, and then offshore we talked quite a bit about those, and the San Jacinto fault, which is broken down into several sectors as well. We've purposely left out the San Andreas because we're talking about all the conjunctive faults all around associated with the greater San Andreas fault zone. So let me see. That's my vocals are way down. Wow.
And when we do San Andreas, we're going to break it down to south, central, and north because that's how they do it too, and all the latest stuff. When we get to that. Yeah. So now the next one I'm going to talk about is the Town Pass fault. And
the Town Pass fault. All right.
Yeah, it's going to make more sense once we see the big map.
All right. Town Pass fault is a normal fault Nearby communities of Wild Rose and Panamint Springs. Most recent surface rupture was in a Holocene at the north end, otherwise the Quaternary scene, which is older. No, younger. Quaternary is younger. Other notes, merges with the Panamint Valley Fault zone. And
so now we're going to talk about Panamint.
All right.
Which is the next.
All right. The Panamint Valley Fault zone is a normal fault type. Its length is 95 kilometers, or roughly 60 miles, I think. Wild Rose, nearby communities, Wild Rose, Ballarat, Panamint Springs. Most recent rupture was in the Holocene. Slip rate is 0.1 millimeter to 2 millimeters at the highest rate in the southern end of the zone. Intervals between major eruptions is completely uncertain, and a probable magnitudes between 6.5 and 7.5. Other notes, a surface trace of this fault zone is very complex, and the faults typically dip to the west. And the Ash Hill Fault, which is part of it, it's near the community of Panamint Springs, and it could do 6 or 7s as well. It's a right lateral to normal as well. So in trying to, and this is from the SCEDC, everybody. So in trying to really, take a look at where this Panamint is, I'll show you. This is the Death Valley. The next valley interior, toward the ocean or toward the central part of California, is the Panamint Valley zone. And with the Hunter Mountain Fault, which is in the north, the Panamint Valley Fault zone means it's a bunch of faults in the same area. And here's Ash Hill, which is in the central part of it as well. And then down at the very southern end is the Brown Mountain Fault. And the Tank Canyon is a splay off of Panamint Valley, which in turn is the Town Pass. And if you remember, we just had several earthquakes in the Furnace Creek. I would say they're off the Town Pass Fault because they're right here at the very top of this area.
Because the next thing we're going to talk about, the next link I put in there, is super new, right off the presses. So that's what we're going to talk about. And it's got maps galore, and dates of quakes, and all sorts of things. So that's the next one.
The Nevada one, or the Owens Valley?
Nope. It should be the one that says Earthquake Insights from like yesterday.
All right. Okay, I got to find it. Let me get it. All right, everybody, just hang in there.
It says Earthquake Insight.
Okay,
the start of it.
I'll find. Remember where we had to just shut it off. Wiki Insights right there. All right. So bringing it over here. Share this tab.
This is the one that Quake Cat put in chat earlier today.
Okay, good. And thank you, Cat. Yeah.
So we're going to go deep into this one because it's
all right.
Really good. So the title is Earthquake Insights, latest earthquake. So this is a couple of like earthquake people talking about this. Okay. So experts. Yeah.
We propose a potential new strike slip fault beneath the valley floor as a 4.7 hit Death Valley.
Yeah. We want to start right at the top and go down.
Okay. People in Eastern California and parts of Nevada felt a rattle around 1 a.m. I did too. I wasn't sure. I said, earthquake? But I may have felt that as well. October 25th of this year, one person in Las Vegas described it as a very light rolling, enough to set the ceiling fan off balance and make the walls creak. That's kind of what I heard too. USGS pager estimates that the more than 3 million people may have experienced weak shaking, although presumably most of them were asleep. Nearly 300 people have reported the shaking of the event. So as you can see right there. But actually, that's not the only earthquake that was reported around this time. 24 seconds after the 4.7, another earthquake reported 4.6 about 120 kilometers to the south. This earthquake did not actually happen and was eventually deleted from the catalog about 6 hours later. Hey, wait a minute, man. I told you it did happen.
Yeah, remember we had all that stuff going on. Well, as earlier today, it was 60 quakes, but anyway,
really 60 going. Quakes. Wow.
Yeah.
And phantom earthquakes reports can happen when earthquake waves caused by one quake are misidentified as a different quake in different locations. In this case, we are told by Dr. Alan Husker at Caltech that the system identified the S waves of the 4.7 as the P waves of a second earthquake, something that is known as a split event. These types of misreports are usually, but not always caught by the system and are generally limited to areas where the network is sparse, like in and around Death Valley. So there's not a whole lot of systems out there. During the 6 hours between when the 4.6 appeared in the list and when it was removed, we spent some time looking at seismograms and try to figure out if it was real. You can find seismograms of the 4.7 here. Boing, dang, 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 dang. Share this tab instead.
And that mystery 4.6, that 4.6 is probably the Blackwater Fault. I'll just say that right now.
Okay.
the one they got rid of. Because it's going to be important when we talk about other things later, which they're not saying that in here. But
uh-oh, what did I just do? Anyway, I'm going to go back to the other one. Yeah. Share this instead. For now, and for the now deleted for one here. Okay. If you look at the stations close to the two earthquakes, you'll see that the second earthquake does not fit the waveform. Errors like this are rare, and they're typically corrected within minutes or hours of scientific manually review the automated picks, as we saw with this event. In time, people are desperately trying to automate everything in sight. It is comforting to know that the experienced seismologists are still at the helm of the earthquake detection. You might have noticed something else in the map timeline above, a swarm of seismicity prior to the 4.7 in Death Valley. Indeed, the earthquake was preceded by foreshocks starting with a 4.2 about an hour before and 13 minutes prior to the 4.7. Those foreshocks seem to just be the latest iteration of a longer seismic swarm that started on October 9th when a 2.9 earthquake. The swarm seems to have been located just to the north of the latest foreshock main shock sequence. There have been some aftershocks since the 4.7, including the 4.3, a few kilometers away. So you'll see all this event happen down in here's the main shock down here. They got the tensor balls already there. Death Valley faults and earthquakes. Today's 4.7 is one of the largest earthquakes to have been instrumentally recorded in Death Valley. The very northern end of the valley experienced a 4.7 in 1945, and a 4.7 event also occurred in the eastern side of the valley at the same latitude in today's event in 1992. While our map doesn't include the southern half of Death Valley, no 4.5 earthquake have been recorded there. But if you follow it through, you got Barstow was what, a 5.2 or something, or was that a 4.7?
And I want to stop and look at this map with the quakes they have on there because they're important.
The lack of large earthquakes recorded might be surprising to those who have spent so much time in the valley, often examining extremely well exposed, large, and apparently young fault surfaces. So I'll zoom in on this.
And so now I want to stop right here and make that map bigger so we can see it.
I just
now, I'm going to start with the ones on the right.
Okay.
Yeah, the 1992 quakes.
Mm-hmm.
You see them on there. The 4.7 and the 5.4, which was over
Mm-hmm. And
going toward the Nevada side.
Mm-hmm.
Yeah, well, guess what? Those 92 quakes were a month before Landers.
Hmm.
So that's pretty interesting.
Yeah, they're not far apart, right?
There we go. Yeah.
Hmm.
Because Landers was July. So I thought that was interesting. And then I looked up to the one at the very top, 98.
Right.
Well, that was the year before.
1999, Hector Mine, yeah. So there is a relationship,
So
a loose relationship, but there is a relationship between them. The 1945 4.7 and the 1944 4.5. You notice that both of those are within that same kind of area as well.
So I looked up 44.
Uh-huh.
I looked up 44. I went into super detail on that one just because I hadn't looked that one up before.
Mm-hmm.
And that was that year there was multiple 6 and 7s in Mexico and in Central America. Mm-hmm. And 44s when Japan went crazy and there was an Nankai trough quake.
Yeah, I think we were talking about. I think we went through 1944 just a few in 45, didn't we? Just a few.
Because
series ago.
Yeah, I think it was one of the Santa Barbara quakes. One of the Santa Barbara quakes. I think it was 44 too, or 45. I can't remember which one it was. And then I saw the 2020 one on August 19th, magnitude 4.7. Well, that was the same year as the Monte Cristo quake, the 7.7 Cayman Islands, and the 5.8 Lone Pine. So right after all those.
All right. So Lone Pine happened also, and we were catching a lot of Mina Nevadas. Were those in 21 or were they in 20 as well?
They were in 21.
Okay.
21.
So you know that earthquake, that serious Ridgecrest to Lone Pine.
Yeah, Monte Cristo was going off around then too.
Right.
Monte Cristo and Mina are all close together.
Right. Yeah, that's what I was trying to get at. Looking at share this tab instead here. Looking at the terrain here on USGS, which we just had another earthquake there. And I gotta fix this damn thing. The Mina stuff was happening right up here. Go ahead.
All these areas were acting up when there was like big movement.
Right.
So it's probably not good that that's acting up.
Right. I'm going to show the history of 30 days, all mags. I want to show you everybody who's being able to watch. Let me make sure this is on the stream here. Yeah, it is. Good. I know USGS won't let me zoom in that much, but you can see this is the last 30 days in this area that we're talking about. The northern sections here, the central section through here, and then the southern section down here. This is the Black Mountain. This is Furnace Creek right up in here. There's that fault system that we just talked about coming out of Panamint, reaching up into where these earthquakes are happening. And if I try to zoom in a little bit more, you can see the red ones are today's, the orange ones are yesterday's, the yellows are further, and then the white ones are even further back. This area is vibrating for some reason. I call it vibrating, but it might be that it's showing signs of stress that, hey, we don't know. It's been, 5 years since Ridgecrest. And if you see in the last 30 days, Ridgecrest hasn't stopped, right? The volume of earthquakes is still happening along these two areas. Then up here by the Coso Range, that stops it altogether going up the Owens Valley. And just recently, we did have a couple more quakes up in the Mammoth Lakes area, which is shut off, virtually shut off. And we are still getting these quakes out here by Indian Springs right here. And sorry, freaking thing. God bless it. Pisses me off. The eastern, here's Betty, right? And Paw Rump is right down in here as well. Right down here. So this area is quaking like much, like a booger. I think Yucca Valley or Yucca Fat is flat, is where they have where they let the bombs off. I'm pretty sure. I'm not too sure, but I'm pretty sure. So this is the area what we're talking about right here. This is the Panamint fault. This is the Death Valley fault. This is the Owen Valley fault. All right. So that's kind of what we're talking about.
I want us to keep reading that same one because they're going to talk about next, like which fault they think it.
Okay. All right. Well, shit, howdy. Where did it go?
It says, oh yeah, it disappears sometimes. You have to go up and click it at the top where it says view this free or whatever, because it did that on me.
Okay.
Go up.
All right.
Make it come back.
So which fault erupted during this event here in this time? That is surprising hard to answer because the small and moderate sized earthquakes rarely cause surface ruptures or significant displacement of the surface. We have to rely on other, less direct indicators. The focal mechanism of the main shock foreshocks give us two options. The fault is either northeast to southwest oriented, left lateral strike slip fault, or it is a northwest to southeast oriented, right lateral strike slip. The foreshock aftershock distribution isn't conclusive. Sometimes a pattern of small quakes lights up a single fault. In this case, there are two trends, a northeast southwest oriented trend defined by foreshocks, and the northwest to southeast trend defined by many aftershocks. That's talking about two different faults waking up. That's what they're going to conclude. You see that there's the trend this way and the trend this way. All right. Now we've talked about the trend of the northeast to southwest trend, but the northwest to southeast trend is a little bit different.
Yeah. And when we talk about Ridgecrest, you'll notice it'll be the same thing. But
same thing, yeah. Let's talk about a map faults that are surrounded area and see if they're good fit. These faults are known because they appear to be surface, usually breaks cutting across the sediments and landforms. The map below shows the fault traces the USGS Quaternary Fault and Fold database. We have labeled some of the main faults. All right, here's the northern Death Valley. Here's the Town Pass Fault, right? Here's the Panamint Valley. Here's the Black Mountain Fault, right? You can see these a little bit better now. All right, so these earthquakes are happening right up in here and here. So that Town Pass Fault, to me, that one's quaking, but also something that leads into the northern valley fault zone. Zone meaning there's a lot of faults in the zone. All right. And Tin Mountain Fault way up here. All right.
Yeah. So now they're going to give the options for
the option here is the biggest nearby strike slip is the North Valley Fault Zone, which is almost a straight line across the landscape of northern edge. All right, you can see that. This is a picture. Bing, ding, 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 right? You can see it. All right. And has plenty of evidence in the quaternary activity. It is a strike slip fault with the correct slip sense to match today's earthquake, but has little to no recorded seismicity along its trace. All right. Could the fault be responsible for the recent earthquakes and the past earthquakes along the same trend? For shallow earthquakes below the center of Death Valley to have occurred in this zone, there would have to be a 7-kilometer systematic mislocation of both the earthquake and a focal mechanism. For regions with very sparse networks, it is possible to get that kind of miscalculation or mislocation. USGS has had that problems before with mislocations, so be aware of that. Here, however, we would translate about 1 to 2 second difference in expected arrival times for the P waves at nearby stations. These seem to be pretty unlikely, and the density of seismic stations in the area on all sides report location uncertainty for the 4.7 earthquake is only, give or take 0.3 kilometers. Pretty close. It could be on the northern section of the Death Valley Fault Zone, or it could be somewhere else. However, it is important to remember that the faults weren't vertical. Earthquakes.
So they mean, the vertical part, they mean that they're at an angle, right?
Okay. So, however, it's important when it aren't vertical earthquakes on them, they can appear to be offset in the map view. Here, it is possible that the northern end of the fault actually dips westward, so that the earthquake is appearing on a deeper part of would appear further west on the map. Can we match the earthquakes with this fault in this way? We draw some cross-section across the Death Valley to try to show how the earthquakes in the valley center line up with the potentially western dipping fault zone of the zone, or the Black Mountain Fault Zone farther deep or farther south in the lower section DD. So this is what we're going to see.
Yeah, so they put lines on there.
Yeah. So they break it down into sectors, eh? So that's what they're doing. And this earthquake is right down in here. And if the fault is along here and it's a west dipping, that means there's part of it underneath this over here. Or is it part of this fault that's dipping this way? So here's the 1992 as well. And up here, the 1945. Seems 4.7 is very popular in this earthquake section. 1944. 2020 on the 4.7. So very, very interesting to the least that this area is ripping at that level, 4.7. And they drew some more pictures here. I'll take these pictures here. Elevation is on the right, distances on the bottom section. Elevation's on the left as well. So watching the different fault zones, 92. It's in kilometers. So the deeper, it does kind of dip a little bit to the left. Well, the black inverted triangles show where the surface faulting is seen at the eastern valley edge. We also drew red lines on the profiles to show the dip of the steeper nodal plane or fault surface for the focal mechanism as cut by the profile. Do the nodal planes align with the surface trace? No. It's pretty clear that the alignment, seismicity, and the focal mechanisms both disagree with the western dipping fault that crops out at the black triangle. Instead, it looks like a more vertical fault existence further west. That's what we're talking about, vertical. Okay, to the west. And to conclude, we don't think the fault zone is a viable host fault for this earthquake or any other recorded seismicity unless something extremely wrong with the earthquake locations in Death Valley. Option 2. What about the more eastern-west oriented fault or the east-west oriented fault? Since earthquake focal mechanisms are ambiguous, presenting two possible fault planes, this is within the realm of possibility. Because looking at the ball, there's a line that crosses it east-west. There's also a line that crosses it northwest to southeast. So that's what they're talking about. The northwest side of the Panamint Range has a spectacular fault system that is exposed to the surface, which also lines up with the focal mechanism of the 4.7 earthquake. The contact between the alluvial fans, the material eroded off the Panamint Mountains and dumped into the range front. These are all alluvial fans, okay? That means the erosion of the mountains come out. This is the dry side. It can happen in the wet, just like on a river. So we don't know if this is underwater made these or if it's just the runoff from the mountains due to all the rain. Would rain in the desert? Yeah, right. The image below is the location of earthquake approximately shown with a red star. Okay, now this is looking basically east. This is the town pass fault. Many thousands of tourists and numerous geology studies have crossed this fault on the way to the Mosaic Canyon, located just near the top of the image above. Note, if you look at the image, you can see that the darker alluvial fan in the foreground is cut by the fault, but the lighter colored fan in the background is not, because some rocks in the desert will acquire a dark varnish slowly over time. The darker fan can be inferred to be older. This is darker, this is younger. And then way up there is the other area that they were talking about. However, this seemed to be a serious problem with the fault being the host fault. First, the town pass fault is reported to have normal sense offset with no known strike slip component. Second, it is not known to be active based on the surface geology. There's no definitive evidence of that either. It is possible that this fault or the similar structure hosted a small magnitude foreshock swarm. Option 3, unmapped hidden strike slip fault below the valley floor. And I think that's what they're pushing. The recorded seismicity in Death Valley shown northwest to southeast alignment of the earthquake beneath the relatively flat valley floor. When focal mechanisms can be determined, they are typically strike slip events on steep faults, which are with one nodal plane that aligns with the larger trend. This suggests that there is actually a big right lateral strike slip fault hidden below the salt pans and sand dunes, which is the most seismically active structure at present. However, strike slip fault of this location orientation isn't present in the USGS Quaternary Fault Fold database or in a Southern California Earthquake Data Center fault map. Why would this fault exist beneath the floor of Death Valley where we can't see it? There's a good reason, and it's a geological reason. The huge hole in the ground that is Death Valley was formed by extreme crustal extension, but this extension was fundamentally linked to strike slip faulting. The Death Valley Chemical Pull-Apart Basin, first described in an article by Stewart in 1966. You can see it, right? And then the area of tension, the Panamint Range, and the Death Valley Fault Zone, right? This type of structure forms when two strike slip faults come close together but don't actually line up. The area between the faults is forced to stretch over time, forming a new sedimentary basin trap between active normal faults. If the faults stepped over the other way, they would instead be a zone of compression. And I think it's very similar to the one between the San Jacinto Fault and the Elsinore Fault, that step over in through, and that's the area of tension as well. I think that's very, very similar to what's going on. And if I showed you out here what I was referring to, oh man, this thing's pissing me off. You go down here to just 7 days. All right, or 1 day. All right, so use this button. Yeah. All right. So zooming in.
So basically, yeah, they're suggesting there's a hidden one they
Yeah.
don't know about northwest, southeast.
Yeah.
On
There's
that
a
side
there's
of the
a
valley.
step over, and we see the step over from the Elsinore Fault to the San Jacinto, right in this region, and we call that Borrego Springs, or the Anza Gap, so to speak, up in here. Oh shit, honey. Right through here, Borrego Springs, right through here. This often happens, and it's a step over because they're two major faults that are close together, but have this sector in between. So I think that's what they're saying. Is that your take as well?
Yeah, they think it's one they don't know that yet.
Yeah.
That's hidden there. So that's what they're saying.
Yeah. All right.
So I thought that was exciting. So now they got another mystery fault.
Or maybe just the movement of both of these faults suddenly created that area of tension, and it created a fault. Maybe it didn't exist before, but all of a sudden now it exists. So that is another opportunity for we didn't exist before. We didn't see it. We didn't know it was there. Well, maybe it wasn't. Maybe it is now after Ridgecrest or whatever happened. However, Death Valley does not have any recorded normal type earthquakes on its boundary faults. It is not clear how much extension is currently happening. Indeed, we see mostly a strike slip earthquake within the valley itself. As a total displacement across the full or pull apart basin increases, it gets harder and harder to keep stretching the crust between. Eventually, the strike slip fault can develop that cuts across the valley, killing off a normal fault as it takes up the slip. This is called cross basin fault zone. These faults are often deeply buried by sediment, and they can be hard to discover. Again, through the southern section of the other two faults I told you, and about this. It's known to be in this kind of area, and it has the same orientation. You know, if this was the San Jacinto and this was the Elsinore, the area of right between the two of them. So it's not unheard of. I think that's probably the most likely event. What's being said there. Do you want me to continue, Canuck?
Well, no, not really, because they just say at the end that they think it's a hidden fault.
It's a buried fault.
It's hiding. Yeah, it's hiding like a Pokemon. They put at the end, so that's funny.
So is there this fault between, or which is in the mountains? I'm gonna zoom in for you. Here's the Death Valley Fault Zone, and here's the other one, and this is the one that said they're thinking that maybe it's in here. It's just not named. It's so damn far down underneath. But it's all based on the basin and range spreading of apart. So it, stuff happens at different levels. All right.
So to me, that's good enough. But what we're going to do now, we're jumping to 2019 Ridgecrest Quakes, because you're going to see how this is a strange parallel once we get into it.
All righty. Where do you want to go?
The next one is the wiki for the 2019 Ridgecrest earthquakes.
All right. I don't know that I've got that.
And this is like super detailed.
That's okay. It's been heavily studied.
Yeah.
And I don't have it in my list right now. So let me try to locate it for you. I know you gave me the link. I just, in recreating it, I somehow missed it.
Lost the.
Yeah, I got the Nevada. Wait, oh boy. No, that is the right grouping. Owens Valley. Wiki. I got you got a Mexico one that you want to share as well. So let me peep that one out. And
that's after.
Yeah, we haven't talked about Owens Valley,
first.
but we're not going there. Oh, here's Ridgecrest right here. All right, I've got Ridgecrest.
We'll do Owens Valley.
Okay, we're good. All right. So, you want to read, or do you want me to read?
Well, I can read this one since you were reading the other one. Yeah. So this one is named the 2019 Ridgecrest earthquakes. The 2019 Ridgecrest earthquakes, more commonly referred to in scientific literature as the 2019 Ridgecrest earthquake sequence of July 4th and 5th, occurred north and northeast of the town of Ridgecrest, California, located in Kern County, and west of Searles Valley, approximately 200 kilometers northeast of Los Angeles. They included 3 initial main shocks of magnitude 6.4, 5.4, and 7.1, and many perceptible aftershocks, mainly within the area of the Naval Air Weapons Station China Lake. 11 months later, a magnitude 5.5 aftershock took place, the largest aftershock of the sequence to the east of Ridgecrest. The first main shock, now deemed to be a foreshock, occurred on Thursday, July 4th at 10:33 a.m. Pacific Daylight Time, approximately 18 kilometers, 11.2 miles east-northeast of Ridgecrest, and 13 kilometers, 8.1 miles west-southwest of Trona, on a previously unnoticed northeast to southwest trending fault, where it intersects the northwest to southeast trending Little Lake fault zone. This quake was preceded by several smaller earthquakes and was followed by more than 1,400 detected aftershocks. The magnitude 5.4 and magnitude 7.1 quakes struck on Friday, July 5th at 4:08 a.m. and 8:19 p.m. Pacific Daylight Time, approximately 10 kilometers, 6 miles to the northwest. The latter, now considered the main shock, was the most powerful earthquake to occur in the state in 20 years after the 1999 Hector Mine earthquake. Subsequent aftershocks extended approximately 50 kilometers, close to 30 miles, along the Little Lake fault zone. Relatively minor damage resulted from the initial foreshock, though some building fires were reported in Ridgecrest near the epicenter. The main quake on July 5th cut power to at least 3,000 residents in Ridgecrest. Effects were felt across much of Southern California, parts of Arizona and Nevada, as far north as the San Francisco Bay Area and Sacramento, and as far south as Baja California, Mexico. An estimated 20 million people experienced the foreshock, and approximately 30 million people experienced the main shock. So then it talks about the foreshocks next. So at 10:02 a.m. Pacific Daylight Time on July 4th, 2019, a 4 magnitude foreshock occurred about 6.8 miles, 10.9 kilometers southwest of Sears Valley, California. A foreshock registering 6.4 occurred at 10:33 a.m. Pacific Daylight Time, 17:33 UTC, 7.5 miles, 12.1 kilometers southwest of Sears Valley. The most populated area near the epicenter was Ridgecrest, home to 28,000 people. The foreshock originated along a strike-slip fault in the eastern California shear zone, a region frequented by earthquake swarms near the edge of Death Valley National Park. The rupture occurred along a 10-mile, 16-kilometer section of an unspecified fault. Earth on either side of the fault was deformed, with lateral shifts of 6 to 8 inches, 15 to 20 centimeters, in the immediate vicinity. The exact fault it occurred on is uncertain, with many small faults encompassing the region, though United States Geological Survey (USGS) seismologist Susan Huff stated it may have been the Little Lake Fault. Focused at a relatively shallow depth of 6.6 miles, 10.7 kilometers, the foreshock affected a large region populated by 20 million people. Residents near the epicenter reported that the shaking lasted approximately 30 seconds. Shaking was felt as far north as Sacramento, California, eastward to Phoenix, Arizona, and as far south as Baja California, Mexico, with evacuations taking place in Mexicali and Tijuana. At 8:19 p.m. Pacific Daylight Time on July 5th, a larger 7.1 earthquake occurred in the Ridgecrest area after being preceded by a 5 magnitude foreshock 3 minutes prior, revealing the previous day's 6.4 earthquake to have been a foreshock. All three earthquakes have been described by the USGS as occurring via shallow strike slip mechanisms. Subsequent seismic activity occurred along two intersecting faults in the Little Lake Fault Zone. Now, the next section here talks about all the aftershocks, and it has a big long chart showing all the ones that were above 4.5, I think. So it has a whole crap load in there going all the way through.
Yeah, there's two faults. I mean, here's the one earthquake, and here's the other, the faulting. The main shock did all these. The other one did these, and so that's part of the sequence that we're showing. And you'll see this is the list that he's talking about: the main shocks, the prequel, or the foreshocks, and then it continued well into August. There was a 5 in Little Lake. So I mean, the sequence started in July 4th and continued into August. And I remember seeing 10,000 quakes plus. Do you want to talk about how it's got the foreshock, main shock, all that?
No, it's just like reviewing a lot of stuff we already said before. And then what the result about the earthquake early warning system is it didn't work the way the shake alert was supposed to. So they changed the threshold of it so that it would. So they talk about that.
I think they've got it pretty ironed out now.
Yeah.
So I know people were getting warnings saying, "Hey, earthquake coming." All right.
But now I want to talk about the tectonic setting one, because that's important, because they talk about how it connects to the other ones.
All right. Tectonic setting down here.
Yeah. So the broad context of the Ridgecrest earthquakes is the Eastern California shear zone, a seismically active region east of the southern segment of the San Andreas, and largely coincident with the Mojave Desert, featuring multiple right lateral strike-slip faults paralleling the San Andreas. It is transected by the Garlock Fault, extending northeast and then east from the San Andreas' Big Bend to the Death Valley Fault near the Nevada state line, passing Ridgecrest about 15 miles to the south. The ECSE extends north along the east front of the Sierra Nevada mountains to Walker Lane, a zone of faulting extending into Nevada and northward, where the Sierra Nevada Sierran microplate that underlies most of Central California is being torn away from the North American continent. Currently, approximately 1/4 of the slippage between the Pacific Plate and North America is accommodated through the ECSC and Walker Lane. It is expected that eventually the shearing will consolidate into a new transform fault that will replace the San Andreas. Along the eastern front of the Sierra Nevada strike-slip faulting happens in the Owens Valley Fault, part of which ruptured in the 72 Owens Valley earthquake near Lone Pine. The OVF runs south largely across U.S. Highway 395 through Bishop, Big Pine, Independence, and Lone Pine to the northern end of Rose Valley and the northwestern corner of the Naval Weapons Center, where the OVF turns slightly to the east. At the south end of Rose Valley, the Little Lake Fault, scene of the 2019 Ridgecrest earthquakes, strikes southeast from near Little Lake, a locale at the south end of Rose Valley, to run under the Naval Weapons Center. The surface trace of the Little Lake Fault is mapped through the northeast corner of the city of Ridgecrest, but due to the dip of the fault, the epicenters of the 2019 earthquakes are mainly under the NWC, where the Little Lake Fault intersects the broad north-south oriented Airport Lake Fault Zone. The fault continues on to the Garlock Fault, about 15 miles southeast of Ridgecrest, just past Searle Station. East of Rose Valley, between the nearly parallel ends of the Owens Valley and Little Lake Faults, lies the Coso Range and Coso Volcanic Field, a notable geothermal field. These lie in a zone where stress and strike-slip movement from the OVF is transferred to various other faults to the south and east, including the Little Lake and Airport Lake faults. The Little Lake Fault has been considered a splay branch of the Sierra Nevada or Sierra Frontal Fault, formed by the uplift of the Sierra Nevada. They actually accommodate a significant amount of the right slip motion of the ECSC, and along with the Airport Lake Fault Zone may be a major tectonic boundary. South of Little Lake, the SNFF continues south along the west side of the Indian Wells Valley, where Ridgecrest is situated, then curves west, roughly along California Highway 14, before connecting with the Garlock Fault. The easterly striking left slip Garlock Fault south of Ridgecrest is one of California's longest active faults and marks the boundary between different styles of tectonic deformation. It has been called somewhat enigmatic in that it appears to neither offset nor be offset by any of the active northwest trending strike-slip faults that cross the ECSC. In particular, even though Little Lake Fault is in general alignment with the Blackwater Fault, its southern extension, the Calico Fault, and a connection is strongly suspected, and though the aftershocks triggered along the entire length of these faults by the 1992 Landers earthquake suggests a structural continuity, yet the superficial geology shows that the Blackwater Fault ends a few kilometers short of the Garlock Fault. How to explain this fault offsetting and the larger question of how strain dislocation is transferred through or around the Garlock Fault remains unanswered. Geodetic measurements show that the slip rate of Garlock Fault is currently less than half of its estimated long-term geological rate. This may indicate that the Garlock Fault is in the late stages of its earthquake cycle. The Scotty Lineament is a zone of microseismicity extending southwest, paralleling the Garlock Fault from near Walker Pass, due west of Ridgecrest, to align with the White Wolf Fault, scene of the 1952 Kern County earthquake south of Bakersfield. The nature of the seismicity suggests an early stage in the formation of a straight slip fault before localized faulting in the shear zone has connected to form a continuous structure. So see what they're saying? They're saying that the seismicity is connecting the faults, but they don't have proof that they're connected under Garlock. So it strikes me funny, all this stuff.
Well, yeah, they kind of bounced around here. White Wolf Fault I'm looking at now. Share the screen instead. Here's the White Wolf Fault here. And here's the Garlock that moves up through here. Here's the Blackwater Fault right over here. And here's the Little Lake Fault and the Searless. Searless is, what the hell is that? I think the Searless is over here. But anyway, so they were saying that the Blackwater doesn't seem to continue beyond the Garlock.
Yeah.
There's no evidence that from up here is connected to down here. However, there are, adjacent faults like Panamint going down here, and then there's faults down here. That just means they could probably be acting the same to northwest to southeast. Some of these look like northeast to southwest, but they act all relatively the same. And I'm not sure how I understood him to talk about how the White Wolf Fault come into play, but I think it's because it goes the same direction as the southern branch of the Garlock that maybe the crossing over. They just don't have any evidence that it reaches, from the Kern River. I think that's what it was saying, if I'm correct. Am I correct?
Yeah. And that Scody Liniment thing, they think it goes between White Wolf Fault and the Ridgecrest area, basically.
Yeah.
So I thought that was interesting.
Well, Ridgecrest is here. Actually, I think it's a little bit over to here. Here's Searles Valley.
I don't see that Scody Liniment on any of the maps I've looked at.
Right. I thought that was interesting too. That's what stood. I went, what? There's a liniment in here, a smaller one. I guess the limit in their usage would be a trend that would just bend in this direction. So I think that's what they mean. Do you have anything to?
No, I want to read the last section, the historical seismic.
Go ahead.
And then we'll figure out where Ridgecrest came from, which we already did before. But
okay.
Yeah. So historical seismicity. A large portion of the slippage between the Pacific and North America plates is accommodated in the Eastern California shear zone, resulting in many large earthquakes, even within the limited span of the historical area. The most notable of these earthquakes is the 1872 Owens Valley earthquake, with an estimated magnitude of 7.4. Preferred, other estimates range as high as 7.9. So it just depends on who you're talking. Yeah, the Owens Valley quake is believed to be the greatest earthquake on record, and not just for California, but also for the Western continental United States. So that's their argument if it was 7.9.
Right, that means it was bigger than a 1906 quake.
Yeah, because they've downgraded the 1906 a little bit, officially.
Quite a bit.
Yeah.
I don't even know what it is.
Yeah, so I'm going to keep reading. In March 1946, a magnitude 6.3 earthquake struck near Walker Pass, crest of the Sierra Nevada, due west from Ridgecrest, with aftershocks continuing for nearly a year. Now, I studied that one because 1946 was when all those crazy big quakes were in the Pacific Northwest. And that was the last time Nankai Trough went off. It was the same year, so in 46.
Right.
So that whole side over there was all going bonkers, but crazy. The 1952 Kern County earthquake, considered the biggest earthquake to hit California since the 1906 San Francisco earthquake, occurred on the White Wolf Fault south of Bakersfield and likely connected with the Walker Pass earthquake via the Scody Liniment. So see, they're talking about this same thing again.
Yeah, this liniment, yeah. Well, if it is, they're talking about the Scody Pass is it's not necessarily it's a fault, but it's an area. So there was an earthquake somewhere out here. I don't. What year did they say? The one was 52, 46.
Yeah.
All right. I'm not sure.
Right, we're going to have to do 52 probably here. Well, it won't be tonight, but
right.
We'll probably have to figure out where that one came from too.
Right.
Yeah.
Well,
So
I wonder if it crosses the if it crosses all the way across, but underneath, where the quakes that are happening last week happened right up here and down this way. There are faults out there, so
because we're eventually when we go back to the intersection, we're going to talk about Pine Mountain Fault and Big Pine Fault.
Yeah, which are out here, everybody.
Which you'll see when we do that, they're slightly offset. But are they lining up with this Scotty liniment and all this other stuff to talk about?
Right.
We'll see about that later.
The Big Pine might, but yeah. All right, continue.
Because the Big Pine and it are a little bit offset.
Yeah,
at
offset
the southern
from
end.
Garlock,
At the southern end of the ECSC, the 1992 Landers earthquake at magnitude 7.2 was also the strongest earthquake in California since 1906. It was followed by a magnitude 7.2 quake on a nearby fault, the 1999 Hector Mine earthquake. Following the Landers earthquake, a well-developed linear pattern of primary and triggered aftershocks was observed that extended along the Little Lake Fault and into Owens Valley. So see, that's interesting. So that's from their
do what?
92.
So what happened again?
They said that linear pattern of primary and triggered aftershocks was observed that extended along the Little Lake Fault and into Owens Valley. So 92, if the size they saw that it went up and crossed.
And that happens down here, and moving up into Little Lake. That even supports where I think here's Barstow. I think something out here, the Blackwater or the Harper Valley Fault or the Lockhart Fault or the South Lockhart Fault, one of these faults have to break to balance the entire system, because you have Landers here, you have Hector Mine here, then up here you have Ridgecrest. However, there was a 5 that kicked Ridgecrest off, so it might have made it go earlier than it would normally have. So I wonder if it released a lot of tension so that the Barstow quake doesn't happen, because the one kicked the other one. So,
well, I think based upon all the stuff I'm reading now, it's either going to be Death Valley or some of the other ones over near that end.
Okay, so it's going to migrate eastward, what you're saying.
And it seems
into the northern shear.
Yeah, and it seems to be alternating as it's coming up, if you just look at sevens.
Okay.
So that's what I think now, based upon all this stuff I've read lately. So anyway, so smaller earthquakes are quite common. In the Ridgecrest area, these include a magnitude 5.2 earthquake in October 1961 near Brown, approximately halfway between Ridgecrest and Little Lake, that was felt in Independence and Los Angeles. Now, this is the first I heard of this one. Mm-hmm. It was preceded by 8 minutes by a magnitude 3.4 foreshock fell in China Lake. So it's the first I heard of this. Mm. Additional earthquakes struck near Walker Pass in 1961, magnitude 5.3. In 1962, magnitude 4.9. In 1979, magnitude 4.3. Well, 79 was the Imperial Valley quake. So that's interesting. Okay. In 1977, 2 small quakes that hit Ridgecrest in February was followed by another pair of small earthquakes in March. So they're given like the list of like all the ones that happened.
Yeah.
That we
Significant
haven't
quakes.
looked up yet, or I haven't looked up yet.
Mm-hmm.
Seismicity in Indian Wells Valley has been characterized by swarms of thousands of earthquakes, some lasting for more than a year. The Ridgecrest Quake sequence of 1995 was particularly notable, having 8 events with
Greater than 4.
and that was the same year as the Klima 8.1. This sequence was similar to the 2019 earthquakes in having 2 main shocks, a magnitude 5.4 earthquake on August 17, located 11 miles north of Ridgecrest, and a magnitude 5.8 earthquake on September 20th, located about a mile south-southwest of the first earthquake. Another shock on the 24th was a magnitude 4.9. Another similarity with the 2019 events, the first earthquake, although occurring on a north-northwest trending fault, presumably the Little Lake Fault, may have involved a northeast trending fault. So see, they're getting into these faults crossing over each other again. It's pretty amazing. Mm-hmm. An earlier study noted that the successive earthquake sequences here tend to increase in number and magnitude and migrate southward. So that was wild, all those numbers they threw in at the end of this. Because I haven't looked up all those other ones.
Right.
But I bet the same patterns going on. There's some of them that I know based on the dates. Because I studied
the Little Lake fault zone that's quaking. It goes all the way to the coastal range. The airport fault zone, we just do a, I'll do a search for the USGS. Okay. Share this tab instead. All right. I'm going to do a search just for the Ridgecrest event so you can kind of see what the hell's going on. I'll do 2.5 or above. It doesn't matter. Custom 2019. And we're going to go, we'll do May. So 05. And we'll stay with 2019. And we'll go to October like we are now. Custom, zooming down into California. All right. We'll start up. Well, shoot, I should do more, huh? Just to see what the hell is happening in our area, right?
Yeah. Well, how far do they go back in this one to?
Yeah, I don't know.
46 or something.
Use this one, and I'm only going in a short time period. I should do 2018 July, so I'll do 6 on this one. All right, so search. All right. So this is the entire segment of 2 and above for that time period, 2019 and 2018, oldest first. Yeah. Starting in 2018, 620. All right. You can see up here, we had a pretty good fair amount of quakes up there in that year. And we're going to go into a little bit of this. You can also see another sector on the Blanco Fault that had a series of quakes. You can see a series of quakes along the Gorda Escarpment. You can see also a trending line coming down through Northern Cal into Western Nevada, and then coming right back down into wherever the hell this area is. It's Walker. No, this is Mammoth Lake, into Mammoth Lake. And then you can also see the greater fault systems that we're working through Ridgecrest and the greater faults that are happening. You can see also this is the trend of this fault, right? These ones out here were happening. We're like, why are they happening up there in the Panamint Valley? Is that thing going to go? And they call that the Searless valley quakes sequence over there. But if you look, here's the where the one main thrust happened, and that leads right into it.
I wonder if you extended that trend, the northeast to southwest one, if it would cut right through where it's swarming now in Death Valley.
Yeah, I wonder. Yeah, pretty close.
That's pretty interesting too.
And you can see down here in where the racetrack was quaking, and you'll see. Look, it's here, then through here, then up through here, and I think this is the area of the quakes are happening right now. It is kind of in that direction, bud.
Yeah,
funny, kind of weird.
All right.
I mean, you'd have to kind of take these top ones rather to get it there, drawing a straight line through, and then leaving it here. Interesting. I wonder if there is a northwest to south, no, northeast to southwest trend of something going through there.
And I think if you extend that line out, which is the theory I was working on back then, and it goes through Montana and then out.
It goes up through Eli and through Warm Springs, through here, up here north of Salt Lake City, right up to the corner of
Salt Lake City had the quake the year after, 2020.
And it goes right towards Bozeman. Yeah, and you're right. There are some quakes up here in Manhattan. Had a series of,
and we saw it do something similar in '92 because the St. George, Utah quake on American fault too. So see, it's like the same patterns. It's pretty interesting.
Yeah. Here, let me draw this. I'm going to take a picture of this, and just to, kind of draw it on the map and see what we think. Desktop, I'm going to do one. Okay. And then I'll go here, and I'll go File, Open, Desktop, one. Okay. I can make that larger. Now over here on stream, so hold on, I'm going to share my other screen. Share the window over here, share this, and then go to here. There we go. So if I were to draw just a line and make it orange, it's kind of hard even to visualize where this sequence went. I'm zoomed out a little too far on that. Sorry. Right through here. Here's the other quakes. I wonder if that's, I don't know. I got to zoom in better and take a better.
Remember, we have Malibu stuff this year too.
Say it again, bud.
We had the Malibu stuff this year too.
Yeah, okay. So there's right through Ridgecrest. Let me draw that. So it is kind of north of this. So
was it going close to the Bakersfield quake too?
Well, let me see here. This is kind of the trend. I'd say that's the trend for what we're seeing. And Salt Lake City came right pretty close to that too. And
my crazy liniments, they're everywhere.
Yeah. So, I mean, if you look on the Idaho up here in the north, that was going, It goes right to the park.
Yeah, that's going the other way. Yeah, the Idaho one. If you were going up to Wasatch,
Right.
things, it would go the opposite way towards Idaho. So that's interesting.
And zooming this is now. I'm going to zoom in the California side and helping us see where the current sequence of events are happening. Look at that line. It's right there.
Yeah, and I know the next fault up in Nevada has been acting the one that goes.
That's where the earthquakes today are happening, where the red X is. So that's pretty darn interesting that there could be a liniment that we didn't know about.
Yeah, that fault that comes down and goes towards Vegas, the opposite way, northwest to southeast, was acting up earlier this year. Remember? I can't remember the name of it. It comes down and goes towards Vegas.
Through Paw Rump?
I can't remember if it goes through Paw Rump. It's got I can't remember the name of it.
Okay.
But it was swarming earlier this year.
Oh, wait a minute. I think I know what you're talking about.
Yeah, it's a northwest to southeast one. It comes down and goes towards
through Vegas. Indian Springs. I think that's Indian Springs.
Yeah, Indian Springs Fault or whatever it's called.
Yeah. And that's
that area was swarming earlier this year.
And sharing this tab again. So what we're saying is, here's Ridgecrest right here in the middle of our screen. This fault system tends to go in that direction. Here's the quakes today. So Ridgecrest to that would lead us through Warm Springs. Let me try to get this for you. There you go. Ridgecrest to here, to through backside of Warm Springs, up through this area, up through the northern part of the lake, and the other drawing had it right about through here. So it goes right through Pocatello, Idaho Falls, and it's right in line with the damn, you know what? The park. Everything leads to the park, right? Can there be, well, I'm just throwing something out here now. Share this tab instead. Can there be some sort of connection? Here's where the supervolcano is up here. Can there be a connection to the park from the volcano here, or the missing one that was down here that's no longer here anymore? Can there be a deep-seated undercurrent of something this direction? I don't know, man.
Well, and you'd have to keep extending it out and see where it goes to once it leaves California.
I'd like to see a map that shrinks Nevada and the West, also Oregon and Washington, from the basin and range, shrinks it back to where it didn't exist, and to see where things are at. And also to do that, if we shrink the basin and range, bring it back together in essence, because it's spreading apart, we'd have to bring a lot of stuff in California back down into Mexico for that to happen. What do you said, 30 million years for the basin and range? Am I right on that or no?
Yeah, I think so. It's 30.
Yeah. What else happened 30 million years
That's
ago?
when all those super volcanoes were going off.
Yeah. Right. Wawa.
Yeah.
And then half that time, again, the one over by me, which is another super volcano that popped. And it's right out here. And it went all the way over to here, to Fort Irwin. So I'm seeing that every day. Yeah, I think it's right in here or right down here.
Well, I guess we're getting bogged down on this now. It's a good hole within the rabbit hole. Well, so now we got to do 2019. Find out where Ridgecrest came from.
Okay, let's find it. List of earthquakes in 2019. Here we go. This is what where it begins. October 26th. Important update readers. Whatever. All right. Okay, we'll start in January of 2019.
Yeah.
Brazil 6.8. Peru 5.0. Argentina a little smally. Chile, way down in Chile, 67. 6.7, I should say. Peru 5.7. Colombia 5.6. That's January. February. Chiapas, Mexico 6.7. That's pretty good. The DR 5.3. That's the Caribbean plate. Peru again 5.5. Look at this. Northern Mid-Atlantic Ridge 6.2. What happened today? Northern Mid-Atlantic Ridge 5.0 today. Hokkaido 5.4. Ecuador 7.5. That's pretty significant right there. That's 7.5 in Ecuador in February. Let's see, Peru again, 7. Wow. So it went south. That 7.5 went south right away. Argentina popped with a 5. Puerto Rico had a 4.6. Bolivia, 6.3. Colombia, 6.1. So now it's going back north. Ecuador again, 6.2. So that's the north western side of South America is Ecuador, just underneath Colombia. Then in April, Alaska, 6.4. Sandwich Island, 6.4. Sandwich Island, 6.5. Hawaii, 5.3. Wow. Western Indian Antarctic is way down south, 6.3. Sandwich Islands again, 6.0. So the south is really banging hard here. India, Yemen. Okay, in May, this is when I joined next door. Because I can sense something was going on, but I didn't know how to explain it. My other daughter did too. Costa Rica came in with a 6. That's about the date. That's her birthday, by the way. Nicaragua had a 5.9. So Costa Rica and Nicaragua banging with 6s. Alaska banging with 6s. Yeah, off the Aleutians. Peru, there's an 8 in Peru. So prior to Peruvian 8 was a Ecuador 7.6, right?
Yeah, and there was a North Peru 7 too.
Hold on here.
Before that, what month it was?
Yeah, there's a 7, right? In March. And the Ecuadorian 7.5 happened in April. So April, he's got a couple of bangers for sure in May.
So South America and Central America on bond.
Yeah, the northern section of it. Yeah, Ecuador and Peru. Yeah, not so much Chile. I don't see much in Chile. Costa Rica had a 6. And we're in May. So that's the Caribbean again. Yep. Neighboring Panama.
El Salvador, 6.7.
Yeah, Nicaragua, 5.9. So it's coming a little bit north. The Aleutian Islands had a 6. There's the 8 in Peru on the 26th. El Salvador 6.6. So that's in the central. Man, 4 days later. In Japan, offshore, Tonga, Chile 6.4. Some New Zealand ones. Pretty good New Zealand ones. Kermitic Islands. Look at that Kermitic. Zing, zing, zing. Bing, bing, bing. I wonder. 3 large ones. And another. And another. And then Ridgecrest area, 5.6 on the 23rd. No. Central part of the U.S. Some damage, such as items knocked off shells, observed. Southwest of Petrolia. All right, that's the Petrolia one. That's when I talked to next door and said, hey, man, this thing can keep coming. He goes, yeah, it can. He was interested in what was happening, too. But what happened to the British Columbia one?
I didn't coming up.
Oh, it did? Okay. Yeah. Panama had a 6.2.
Yeah, that's the one I thought was in Costa Rica, but it was.
Yeah, it's right on. It's on the border. Yeah.
So that was like a week before Ridgecrest.
All right, and then July. I don't want to. All right, Canada, British Columbia offshore 6.2 on the 4th. Port McNeil.
Yeah. And it had a 6.2 and a swarm of 5s.
Yeah, it had several other ones as well. And then Searless Valley came in with a 6.4. And then Ridgecrest did the 7.1.
Yeah.
There's Greece in the mix again.
Yeah, it's interesting.
So what we see is the Pacific Northwest. I mean, not Pacific Northwest. There is one quake there prior to it. We see Nicaragua. We see Salvador. We see the Caribbean. We see Costa Rica. We also see the Mid-Atlantic.
And if you go back into the end of 2018, it starts with the Fiji 8.2, and then there's a whole bunch of 7s at the end of the year, including the one in Anchorage at the end of 2018.
Okay, looking at 18 now.
And 2018 was also when
Honduras
Kilauea had the big eruption too.
All right, so we got Honduras with a 7.5. We've got El Salvador with a 5.2. Peru with a 7.1. Mexico with a Baja Mexico, central part, 6.3, Laredo area.
And 2018 was
Chile
also the big fire, Paradise and Campfire and all those.
Alaska had a 7.9.
Yeah, that was when Kilauea erupted. I think around the same time. I think. No. What was the date for that one?
23rd of January 2018.
Yeah, because I forget when Kilauea was. I think May.
All right, so
when it officially
pretty good Peruvian quake. Baja, Central Baja's popping. I think I started looking at next door about this time. I kind of run across them. 7.9, pretty strong. Gohu, Alaska. Ecuador 5.2, Central America or South America. Oaxaca had a 7.2. Moving north.
Yeah, because there's a lot of stuff going on in 2018.
March. Oklahoma had there's the interstate right there. Oklahoma, 4.2. Everything that happens in California, something happens across the United States. We see it coming through, leading into it. So, and then April, it's like a year before though. El Salvador 5.9.
Yeah, see if we do Ridgecrest. It was the first quake was July 4, right? So
offshore Santa Cruz Island 5.3. And this one is offshore.
You'd be
that's off of Garlock, the Santa Cruz Island quake. That's a 5.3 that happened in April of 2018. Yeah. That's interesting too. Chile 6.2. Venezuela.
I think it was May. I think it was May when Kilauea blew up.
Okay. Chile had a 6. Hawaii, 6.9. There you go. On the 4th.
There was
the 4th of May.
Yeah.
El Salvador 5.4.
Because there's always a big quake whenever it erupts there.
5.0. Ecuador again. Seemed like Ecuador and Peru just banging. Boom, 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 boom. Colombia 4.9. In July. Colombia 5.1.
August is when
Mid-Atlantic Ridge. Look at that. Mid-Atlantic Ridge in July 2018.
Yeah.
So I'm going to be watching what happens after this. August. Alaska 6.4. Alaska 6.4. Indonesia Lombok 6.9. Costa Rica 6.1. 8.2 Fiji, and 6.3. Yeah. Venezuela 7.3. Wow. Oregon 6.2 offshore, west of Brandon. The Aleutian Islands had a 6.2. Peru had a 7.1. Man, it really banged real hard in August.
Yeah, in September, October was the Paradise and Campfire.
Okay.
2018. I think it was September, October.
Fiji 6.7 again. September, October. Haiti 5.9. Bunch of Russians. Canada, Vancouver 6.5, 6.8, 6.5.
Wow. Yeah, that was those 3 6s I slept to, and I was all mad. Remember.
And then Greece had a 6.8. Yeah, I think I remember this one a lot. Yeah. El Salvador 6.1. Peru 4.5. Drake Passage 6.3. And in November, Chile 6.2. North Atlantic Ocean 6.3.
Yeah.
The East Pacific Rise. Yeah, I don't know where the hell this one is. Okay, it's down there, down in the sound, but it didn't say exactly where. Peru had a 5.5, Venezuela had a 5.2, Colombia had a 6, and Alaska had a 7.1. And then in December, Pacific Antarctic Ridge 6.3, Chile 6.3, Venezuela 5.4. Alaska 6.0. We've done it. We've done them all.
Yeah. And I think it was Solar Man at that time.
Yeah. Well, we're seeing the same kind of patterns persist even on this quake.
Yeah.
And if we went to 2020, I think we would see the quakes that took place in Utah and the other one.
Yeah.
Mexico, Oaxaca had a 7.4. Alaska had a 7.8 in 2020.
Yeah, the Oaxaca one. The Oaxaca one was the day before the Lone Pine 5.8.
All right. So in January, let me see where we at. Yeah, January had a busy month. Freaking frack. Puerto Rico 5.8, 6.4. I remember the Puerto Rico quakes. Oaxaca had 5.9. Puerto Rico 5.2. Puerto Rico 5.9. I thought it was going to really rip. Argentina had a 4.5. Oaxaca 5.2. Kansas 4.5. Aleutian Islands 6.2. 6.1. The Cayman Islands 7.7.
Yeah, that's on my birthday.
Yeah, on the 28th. Yeah, January. Interesting.
Liniment.
What's that again?
Texas Liniment.
Texas Liniment. Okay.
Yeah, and Ridgecrest was in 2019.
Yes.
Mm-hmm. And then in 2021 we had the La Soufriere eruption.
There was one quake off of Oregon as well. That's on the Texas in my mind, but
yeah.
Into March, Mexico, Baja 5.5. Utah 5.7. That happened in March 18. East Pacific rise again. Then Idaho a couple days later on the 31st, a 6.5. So we have big quake in the middle, and then not quite a year later, we have quakes in the central part of the U.S. Also coming out of Alaska, big quakes in 2020. And there's a whole lot of movement, man.
And once you get into 2021, is our 3.8, which was the last 8s we had 3 years ago. See, so it was like building until we got 3.8.
Then Nevada's the month later. Yeah. And Greece is in there 6.5. Puerto Rico's still banging around. And that all happened in May. Big Sur 6.1. Peru 6.1. Chile 6.8 in June. So we're almost a year after Ridgecrest.
Yeah.
Mexico, Oaxaca 7.4. Lone Pine came in with a 5.8 the day after Mexico's Oaxaca.
Yeah.
And there was a Baja, wasn't there? Month before, 6.1. So a lot of activity going up the coast there. Puerto Rico's still banging really hard. Really big quakes, 5s. Chile, 5.9. Perryville, Alaska, 7.8. Then Sandpoint, Alaska, 6.1. They downgraded that 8 to a 7.8. The Alaska quake.
Well, there's 3.
Yeah, 6.1 Sandpoint.
There was 3 Alaska quakes. The first 2 were like 7.8, and then the last one was 8.2. And it started 2020. There's one in 2020, like October, I think it was. And then there was 2 in 2021. I think that's how it went.
Well, all of Chile quaked with 6s, 6.8, 6.3, 6.5, 6.3. All of Chile up and down. 6.2.
Because there was 3 large quakes at Sandpoint over
the Mid-Atlantic Ridge comes in with a 6.9. There's the central Mid-Atlantic Ridge. And then South Almani and Los Angeles, 4.5. That scared the hell out of everybody again because of Ridgecrest. Then Sandpoint, again, 7.6. 7.8 and now 7.6.
Yeah.
And in November...
Because there's 2 sevens.
46. Massachusetts,
Sandpoint,
46.
8.
Yeah. Argentina.
In 2021.
December. 6.4. Greece again. 6.4. 4.5. Antarctica, the Bellini Islands, 6. Chile, 6.1. Chile, 6.0. Peru, 5.6. Peru 5.7, Chile 6.7. Croatia was banging pretty good back then, and that I didn't see. I think they downgraded those 8s, bud.
And no, the 8.2 was in 2021. Because the 2 7s at Sandpoint were 2020, July and October, I think.
Yeah, it had no 8s in 2020. Yeah. So they have since
2021 3 8s.
Yeah.
Sandpoint, South Sandwich, and Perms.
Right, but I saw the Japanese going too. So, yeah, they got 3 of them, and I think Japan had several 7s, but they were downgraded. 8.2, 8.1, 8.1. New Zealand, Kermadec Islands, South Sandwich Islands. Hey, they kept the 2 8s. And I argued that point, and they kept going lower. And now they back up to 8.1s. No, I'm sorry. The New Zealand Kermadec Islands. I saw 2 8s in there. Like the 2 7s I saw in Japan. They only have 1.
Well, 3 that year officially.
Right. Mexico. Guerrero had the 7 as well. That's the the Guerrero quake. That's what the hell?
See, I don't like when they call it, because wasn't that the Acapulco one? Was that?
Yes, that's what I'm trying to say. The city, Acapulco, right here. Yeah.
I don't like when they give the
county or the state. Province. Yeah, or province, right. Well, that's pretty good.
So you just did like 4 years of quakes from 2018 to
right
2021.
Yeah.
So we went almost 2 years before Ridgecrest, or a year and a half.
And did you want to talk about the Nevada sequence, or you want to not? Because it was on your list.
Yeah, we should do. What are we at now? 2 hours.
Yeah.
No, 3 hours.
We're 1.4.
Well, yeah. We had the mess up in between. So.
We didn't do the Owens Valley. Why don't we save that for the next time? We'll start with Owens Valley.
We should probably do Owens Valley and then
Nevada.
1950.
Yeah.
A Chappie one.
Yeah, let's save that for the next time. We'll continue this. Yeah. Seeing how we did have that kind of mess up in the middle.
Yeah.
Because I know we're already 1 hour and 47 here. I don't know what it was before.
Yeah, probably at least
All right, so this will be a 3-parter, everybody. Thanks for the help. Thanks for listening, and remember, don't get none on you.
Everybody's probably gone to bed by now.
Yeah, I don't know, but I think it's really interesting. All right, in stream.